Hello viewers, today our topic is altitude and its intersection point is orthocentre. So we are going to look at altitude and orthocentre and its properties. Here I am taking triangle ABC, AD, BE, CF are altitudes of this triangle. So here it is 90 degrees, 90 degrees. The intersection point you call it as a orthocentre. Look at quadrilateral AEOF. In AEOF, angle F and angle E, both of them are 90 degrees. Therefore, sum of these two angles is 180 degrees. Now, rest of two angles, angle A plus angle EOF is equals to 180. Now, angle EOF is equals to 180 minus angle A. Therefore, angle BOC is equals to angle EOF because they are vertically opposite angle. So, if this is angle A, this angle must be 180 minus A. Therefore, angle BOC is equals to angle EOF because they are vertically opposite angles, 180 minus angle A. So, look at this triangle here, angle A, B, C. O is the orthocentre. We know angle BOC is 180 minus A. Angle A, or else you can also say it is 180 minus angle BAC. Look at angle COA. Now here this angle is B, therefore it becomes 180 minus B. 180 minus angle ABC. If I take angle AOB, which is equals to 180 minus angle C, 180 minus angle ACB. This is 180 minus A minus B. This angle is 180 minus angle C. So, angle which is opposite to A here is 180 minus A at the center. So, at the orthocentre angle formed is 180 minus A, here 180 minus B, here 180 minus C. Let us take the triangle ABC. Here the intersection point of altitudes AD, BE and CF is O. We know angle BOC is equals to 180 minus A. If it is 180 minus A, this and angle BOC forms a linear pair. Therefore, if it forms a linear pair, the sum of angles must be 180. In order to make it 180, you have to put the value A here because this is 180 minus A. So, angle COE and angle BOF. So, you can say angle COE, angle BOF, both of them becomes angle A. In the same manner, this is angle A and this is angle A. Look at angle B. Here if it is angle B, this becomes 180 minus B. Therefore, this is also 180 minus B. Therefore, rest of angles forms a linear pair. So, this is B and B. So, we can say this angle is B, this angle is also B. So, AOF is equals to COD is equals to angle B, and the rest of the angle becomes angle C. This is C, this is also C. Angle AOE is equals to angle BOD is equals to angle C. Now look at, there are 6 triangles here, 1, 2, 3, 4, 5, 6. There are 6 triangles. You closely observe triangle 1 and triangle 4. If you observe triangle 1 and triangle 4, we all know that these are right angles. In triangle 1 and triangle 4, and also observe triangle 2 and their opposite triangle 5, triangle 3 and opposite triangle 6. Observe these 2 pairs of triangles. You will understand angle C is angle C, 90 degrees is common in both, therefore this angle, if I take it as theta 1, this angle is also theta 1 here. So all the 3 angles of one triangle is equals to all the 3 angles of the second triangle, therefore these two triangles are similar triangles. So you can say these 2 triangles are similar triangles. So you can say these are similar. In fact, if any one of them becomes equal, then it becomes congruent. Okay. So it depends on the question, but as of now we can say those are similar triangles there. Now look at the question based on the look at this question. In an obtuse angle triangle ABC, angle A is an obtuse angle and O is a orthocenter. If angle BOC is equals to 54 degrees, then angle BAC, angle formed at the orthocenter, that is BOC, whether it is acute or obtuse, angle BOC is equals to 180 minus angle A, or else you can say 180 minus angle BAC, and vice versa. If I ask you what is angle BAC, it is 180 minus angle BOC. So here 180 minus 54, answer is 126. Look at the next question. In a triangle ABC, O is orthocenter, angle A is equals to 50, angle B is equals to 60, D is the foot of the altitude on BC, then BOD. See here, angle A, B, C, D is the foot of the perpendicular on BC. It's asking you BOD. Just now we have seen BOD means if it is C, this becomes 180 minus C. If it is 180 minus C, here this is C. So angle BOD is equals to angle C. Now how do I get angle C? 180 minus angle A plus B. So 180 minus angle A is 50, angle B is 60, therefore 110, remaining angle is 70 degrees. So the required angle BOD is same as angle C. We have seen this in the properties just now. Look at the next question. The sum of 3 altitudes of triangle, if I take one altitude, if I take this angle theta, this theta is always less than 90 degrees and the side is opposite to 90 degrees. If I consider this particular triangle 1, in this triangle 1, obviously side AB, if I take it, side AB is opposite to altitude, therefore I can say it is called hypotenuse. It is opposite to right angle, so it is called hypotenuse. Hypotenuse is a larger side in a triangle. In any triangle, hypotenuse is a larger triangle, larger side. Therefore you say AB is greater than this particular altitude. Let's say this altitude is H1. So AB is greater than H1. In the same way you can say H2, H3 also. If you do sum of all the sides, it is greater than sum of all altitudes. Therefore sum of altitudes is less than the sum of sides. So the correct answer is less than the sum of sides. The orthocenter of a right angle triangle lies We have already seen the orthocenter. For an acute angle triangle, it stays inside. For an obtuse angle triangle, it stays outside. For a right angle triangle, it stays exactly at the right vertex. So, at the right vertex, answer is B here. O is the orthocenter of triangle ABC, then angle BOC plus angle BAC. See, BOC, we have just now seen that it is 180 minus angle BAC. You can call it BAC or else angle A. BAC and angle A, both of them are same, plus angle BAC. So, angle BAC gets cancelled. Answer is 180. Next. O is the orthocenter of triangle ABC and BOC is equals to 110, BAC will be. So, angle formed at the orthocenter and angle A. If I ask you angle BAC, it is 180 minus angle A, sorry, angle BOC. If I ask you angle BOC, it is 180 minus angle A or else angle BAC. If I ask you angle BAC, then it is 180 minus BOC. So, it is vice versa, 180 minus 110, which is equals to 70. If I give you angle A 70, then BOC becomes 110. If I give you BOC is equals to 70, then angle BAC is equals to 110. Now, we look at perpendicular bisector. And its intersection point, circumcenter. So, circumcenter is nothing but you have to draw the perpendicular bisectors which bisects the side and it is perpendicular to the given side. Bisects the side and perpendicular to the given side. Circumcenter means there is a circle which passes through all the three vertices. So, if it passes through all the three vertices, like this it passes. So, when it passes through all the three, we can say circumcenter is equidistant from vertices. When it comes to incenter means you can draw a circle inside. Therefore, I would say it is equidistant from all the sides. This is incenter. So, remember, incenter is always equidistant from the sides given and circumcenter is always equidistant from the vertices. These two are very, very important. Now, let me take a triangle inside a circle. Now, we will see what is an angle formed at circumcenter. So, I have taken a circumcircle and a triangle and exactly I am looking for the angle which is formed at the circum. Here O is the circumcenter. Just take an imaginary line here. Let us say this angle is, this is radius of the circle, this is also radius of the circle. If I take it as angle x, this is also x because it becomes OAB is a right angle, is an isosceles triangle. Two sides are equal, then their opposite angles are also equal. If I take this as y, this is also y. Angle OCA is also y because it is an isosceles triangle. Both OAB and OAC are isosceles triangles. So, these two angles particularly equal. If you look at this particular angle, I told you in a triangle the external angle is sum of two internal angles. If it is angle A and B, this external angle is A plus B. Here also I would say this is an external angle to the triangle OAB. So, this angle becomes x plus y. Here this angle is also becomes x plus y. So, BOC becomes 2 times of x plus y. Now, what is angle x plus y here? X plus y is angle A. So, it is 2 times of angle A. So, at circumcenter the angle formed is 2 times of angle A. Remember, at incenter, orthocenter, circumcenter. Centroid we don't find the angle. At incenter it is 90 plus angle A by 2, the angle formed. Orthocenter it is 180 minus A. Circumcenter it is 2 times of angle A. It's very important. These three are very important. See this question here. If S is the circumcenter of triangle ABC and angle A is equals to 50 degrees, then the value of angle BCS is, if S is the circumcenter ABC, if it is 50, obviously at the circumcenter it becomes 100 because it is double of it. Now he is asking you BCS. If I take it as theta and theta, I can say side BS is equals to side SC because this becomes the radius of the circumcircle. It becomes the radius of a circumcircle. Therefore, BSC, triangle BSC is isosceles. If it is an isosceles triangle, these both of them are theta and theta because it is an isosceles triangle. 2 theta is equals to 180 minus 100, that is 80 degrees. Theta is equals to 40. So answer is 40 degrees there. In the given figure, OX, OY, OZ are perpendicular bisectors of 3 sides of the triangle. Triangle QPR is 65 and PQR is 60. QPR is nothing but angle P. Angle P is equals to 65. Angle Q is equals to 60. Sum of these two angle becomes what? 125. Therefore, angle R is equals to 55 degrees. These are perpendicular bisectors. Therefore, I would say O is circumcenter. I am getting the same figure here, but with the different names. Let it be P, Q, R, O is the circumcenter. Slightly different. Here R is 55 means angle POQ is equals to twice of 55, that is 55 into 2, 110. If this is 110, he is asking you the value of QOR plus POR. So you want QOR plus POR. So you need rest of the angle. If it is 110, complete angle is 360. The required angle 360 minus 110, which is 250 degrees. So answer is 250 degrees there. Here O is the circumcenter of triangle BABC if angle BAC is nothing but angle A is equals to 85, angle C is equals to 75. Then he is asking you OAC is equals to. So from here we can get angle B is equals to 75 plus 85 becomes 160. Therefore, angle B is equals to 20. Imagine triangle ABC. I need OAC. We are interested in this angle. We know if it is theta, this is also theta because we have seen the similar sum. Angle B is 20 means this becomes 40. So 2 theta in the triangle is equals to 140. So theta is equals to 70. So basically if B is given, how do I find out this OAC? See there. In a circumcenter, triangle ABC, O is the circumcenter, therefore this becomes 2A. This angle is A. Theta and theta if I take it. Triangle angle OBC is equals to theta. Now 2 theta is equals to 180 minus 2A. theta is equals to 90 minus A. Simply remember that it is 90 minus A. Just remember that angle is 90 minus A here. This is also 90 minus A here. You can directly find out. Here, the moment you get 160, it is 20. So, therefore, this is 90 minus 20. Answer is 70. Next one. O is the circumcenter of triangle ABC and OD is perpendicular to BC. Then angle BOD must be. O is the circumcenter of triangle ABC. This is a circumcenter. OD is perpendicular, he says. Then he is asking you BOD, this angle. We know this is angle A, therefore it must be. If you observe these two are actually congruent because it is perpendicular bisector. This is radius, this is radius, this is a common angle only. Therefore, angle BOD is equals to angle COD is equals to A, because both sum is equals to what? 2 times of A. Therefore, BOD is equals to what? A. So, which is equals to angle A there. If O is the circumcenter of triangle ABC and OBC is equals to 35 degrees, then the angle BAC is equals to, it's a circumcenter, O is a circumcenter. OBC. If it is 35, the opposite angle is also 35. Therefore, 70 means it is 110. Therefore, this becomes 55. Or else you can say angle A is equals to 90 minus angle OBC, or else angle OBC is equals to 90 minus angle A, vice versa. If it is 35 means rest of the angle is 55. Just now we have derived it. O is the circumcenter of triangle ABC given BAC means angle A is equals to 85, angle C is equals to 55. Find OAC. So, we know angle OAC is equals to 90 minus angle B. What is angle B here? 85 plus 55, it is 140. Therefore, OAC is equals to 90 minus angle B, 90 minus, so it is 140 minus, okay, 180 minus 140 is equals to 40 here. 90 minus 40 is angle 50. Now, look at the last question. Here, I and O are respectively incenter and circumcenter of triangle ABC. The line AI produced intersect the circumcircle of triangle ABC at the point D. If angle ABC is equals to x degrees, angle BID is equals to y degrees and angle BOD is equals to z degrees, then z plus x by y is equals to. This is the figure I got here. I and O are respectively incenter and circumcenter of a triangle ABC. The line AI, which means is produced to intersect the circumcenter at D. Here I am taking the incenter I. Incenter is actually an angular bisector. Of triangle ABC at point D, and angle ABC is equals to x. Angle BID, so BID is y. This everything is x means this is x by 2, this is also x by 2. So, it is x by 2. Now, you take circumcenter somewhere. if I take BOD is equals to Z, angle BOD is equals to 2 times of angle BAD, which is equals to Z. Therefore, angle BAD is equals to Z by 2. So, observe carefully, concentrate on the triangle this one, it becomes Z by 2. Now, look at this triangle BAI. For BAI, the external angle is Y, this is X by 2, this is Z by 2. Therefore, Y is equals to X plus Z by 2. So, X plus Z by Y is equals to 2. So, here we have used circumcenter and also in center properties both. So, external angle becomes Y, that becomes sum of two interior angles X by 2 plus Y by 2. So, X plus Z by 2. So, Z plus X by Y is equals to 2 there. So, in this video we have seen the properties of circumcenter and orthocenter, and what is the angle formed at the orthocenter and circumcenter when altitudes and perpendicular bisectors intersect at the respective centers. So, thank you.